Okay, good morning. So, Morten is going to join a course for a physics teacher next week. So probably we will combine two groups together so that I will teach. That's why I will not teach today, because otherwise we cannot have the same two groups in one lesson. But I decided to solve some problems for you regarding the complex numbers, and I probably choose some of these hard problems from an Indian book again. But this one I don't know. Let us see how I can solve it myself. There is a problem here you are supposed to calculate. Do you remember? I just want to remind you about what we learned last time. Yes, did I talk about exponential form of complex numbers? Yes. So we realize that if we have three forms of for complex numbers. The standard one, or the Cartesian form, is this. And then we also learned that we can write any number in this form. The complex number can be written in its polar form. Yes? Where r is the absolute value of the complex number and theta is actually the argument of that. And then we learned another formula that is important, that was Demoire's formula. Demoire's formula told you that if you have cosine theta plus I sine theta, yes, and you raise it to power n, it becomes what? It becomes it becomes cosine n theta plus I sine n theta, yes? Where, of course, n is an integer. Yes, that was Demoire's formula. But then we also learned about Euler's formula. I tried to motivate you why this is correct, and we learned that this combination, actually, cosine theta plus I sine theta, can be written in this form, e to the power of I theta. So that is this is Euler's formula. And then I told you that for using Euler's formula, you have to have theta expressed in radians. Otherwise, this will not work. So, of course, here, for the left-hand side, it doesn't matter if you express theta in radians or degrees. But if you want to have this equality, then theta should be expressed in radians. Okay, and then of course I didn't talk about that. You see that if you already knew about Euler's formula, Demoire's formula is an immediate consequence of that. Yes, why is that? For example, assume that first you knew about Euler's formula. And then you want to find Demoire's formula. It is easy now, yes? You start from the left-hand side. You say that, okay, instead of cosine theta plus I sine theta, I will write e to power I theta. Yes? And then I have a power of n there. So I multiply it here. This becomes this expression. Yes? But now I give the role of theta to this one. So let me call it capital theta, for example, something like that. And then what you see e to the power of I capital theta. But then again, you can use the Euler's formula, yes? You can write cosine capital theta plus I sine capital theta. But then at the end, you replace capital theta with n theta. So this becomes cosine n theta plus I sine n theta, yes? And that's exactly Demoire's formula. So we started from the left-hand side and we reached the right-hand side. So what I'm saying is that if you knew about Euler's formula before Demoire's formula, that was an immediate consequence of the Euler's formula, yes? This becomes the right-hand side. First of all, this is good to know. Any questions here? Okay. And then, because of the Euler's formula, this part can be written very nicely as r e to power r theta. So probably this is a very, very nice compact form of writing a complex number. And this is called the exponential form of the complex number. Yes? so let me actually ask you to solve a problem which is here. We are supposed to calculate this sum, sigma. K goes from 1 to 10, and then cosine 2k pi over 11 minus I times sine 2k pi over 11. So we are supposed to calculate this sum. There are 4 answers given: 1, -1, I, and -I. Okay, but might be you need a little bit of experience to be able to solve this problem. So you see that if I just want to start answering this sigma by expanding the sigma, then I will get 10 terms, and then I have to collect the real parts together, and then I can factor a -I, and then I have to collect the signs together, yes? But the problem is that how can I calculate that sum of 10 terms in cosine, sum of 10 terms in sine, yes? Because the answers, as I told you, are super simple. The answers provided as the options is 1, -1, I, and -1. So they are claiming one of these are the answers, okay? So the point is that I should be able to calculate these things. But I hope that somehow you feel the connection of this expression here with this expression there, yes? The only difference is that instead of having positive I have negative I. But if you have enough experience, that is not a big problem. Do you remember? How can I get rid of this negative sign to make it positive? So we have what? This is the trigonometric formula, yes? Sine of minus alpha is minus sine alpha. But cosine of minus alpha is equal to cosine alpha, yes? It's very important to remember these things, okay? So what I do, I would write this as sigma. K goes from 1 to 10. And then what I would write cosine. Instead of this one, I write minus 2k pi. The reason is that I want to make the angles exactly the same for cosine and sine. Then I move this minus sign inside, it becomes positive I, then it becomes sine of minus 2k pi over 11, yes? Yes or no? And now you see that this is exact combination that I need. I have cosine of an angle, the angle is this guy, plus I times sine of the same angle. So that is the right combination that I need, yes? Do you agree? So, but now I can use Euler's formula. Write it more compactly, yes? So this becomes the sum that you will see why this is interesting now. So this sum becomes sum k goes from 1 to 10. Instead of this expression, I write E, I, 2k pi over 11. That's it. Is that right? I was able to get, so here, oh sorry, and the negative sign. Negative sign. So here this expression is the Euler formula, yes? But the angle is this angle. Do you see that? It is cosine of an angle plus I sine of the same angle. So according to Euler's formula, it can be written as e to the power of I, e to the power of I, multiplied by your angle, which is this number. Yes, so that is it. I have to calculate this sum. But you might say why this is beneficial. You will see why. First of all, if you don't mind, let me try, so you see this k is changing from 1 to 10, and it appears here. Because to make things simpler, if you don't mind, let me give this a name. Instead of minus 2 pi over 11, having it over my head all the time, let me call this one alpha. yes, to make life simpler. That's a constant, 2 pi over 11 multiplied by negative sign. It's a constant, so let me call it alpha. But alpha is known to you. You don't have any problems with that. The only problem is I want to make it simpler, yes? So k goes from 1 to 10, and then this becomes e I k times alpha. So let me wait for you. Is that understandable so far? Yes? But why this sum is easier to calculate than the original sum, even though they are equal? So this line of reasoning shows you that it doesn't matter if I answer the question mark for this sum or answer the question mark for this sum. But my claim is that this sum is easier to calculate than that sum, not because it is simpler in form. There is another deeper reason why this sum is easier than this sum. I mean, the answer to this question might be that, okay, it is clear, because this is very simpler and compact. This is a little bit bigger, so this should be simpler. But there's a better reason for that. And why is that? Let me expand this. Might be you can understand what is going on. If I expand this sigma, what is the first term? Instead of k I put 1, I get e to power I alpha. And then let me put 2. It becomes e to the power of I 2 alpha. So let me write 2 I alpha. The next one becomes e to the power I 3 alpha, 3 I alpha. And this sum will continue until the very last one. Alpha. Why this sum, calculating this sum is easy? I am claiming that if it was from 1 to 100, it's still simple. If it goes from 1 to 1000, it's still simple. Why is that? You see, the way that you have to think in this way, in these courses that you have two sums, famous sums. Arithmetic progression sum or geometric progression sum. Because in those cases we have a formula. But which one of these sums are here, yes?
Can you factor out e to the power I alpha?
You can factor it, but that's not my question.
But then there's a geometric progression.
Yeah, that's also geometric, so you don't need to factorize. But for a geometric one, in the way that I have written it down, this is the first term. But can you tell me what is the common ratio R? Every time, if you claim that this is a geometric sum, it means that there is a constant number which is multiplied every time to get the next one. What is that constant number? E to the power of I alpha. Yes? Every time, e to power I alpha multiplied by e to power I alpha becomes e to power e to I alpha. If I multiply it by e to the power of I alpha again, I will get that one. So this is a geometric sum. That is the reason that this is simple to calculate. If you expand the sum originally, this becomes a sum of cosines, and that becomes a sum of sines. But they are not geometrical progressions, they are not arithmetic progressions, yes? So that's the reason we can calculate. Okay, so the only thing that you need to do is to go, if you don't have it in your memory, you refer to the geometric sum formula so that I would write it here for you. So this Sn for geometric sum was what? 1 minus r, and then first term 1 minus r to power n. R is the common ratio, and n is the number of terms involved. Of course, here it is clear I have 10 terms involved, so n is 10. But what is r? R is e to power I alpha. Okay, so what I will write, I will use that formula. So this becomes e1, which is e to power I alpha, and then 1 minus r to power n, but here I have 10 terms, and then I have divided by 1 minus ei alpha. Yes? So at least I succeeded yes. So I succeeded to sum them up. It's a closed formula. Do you remember what I mean by closed formula? Something's equal to that one without these dots. That's a closed formula. But of course, it is far away from the answers provided. So you have to convince yourself which one of these numbers is equal to that number. So what should I do here now? So let us try to simplify this as much as we can. Okay, so what I want to hear from you, what is the first step? Probably I have to write something for this one, but that becomes 10 alpha, yes? So this becomes e to the power of I alpha, 1 minus e to the power of 10 I alpha, divided by 1 minus e to the power of I alpha. But then let me multiply this in. It becomes e to power I alpha minus e to the power of 11 I alpha divided by 1 minus e to the power of I alpha. Okay, you might say that, okay, how should we do that? Don't forget, what was alpha? Alpha was this number that I introduced in the beginning. Okay, so let us concentrate on this bit first. E to the power of 11 I alpha is equal to e to the power of 11 times I times alpha. Yes? But this 11 here and that 11 are cancelled out, so this becomes e to the power of minus 2 pi I. Yes? But this is extremely simple. Can you tell me what the answer to this is? The Eulers formula is still on the board. E to the power of I times an angle expressed in radians can be written in this form. Yes, so I can write it back. But this is playing the role of that theta in the Eulers formula. So this becomes cosine minus 2 pi plus I sine minus 2 pi. Yes? But what is cosine minus 2 pi? It is 1, sine of minus 2 pi, 0. So the answer is just simply 1. So e to the power of 11 alpha is 1. And then I put it back here. So the question mark becomes equal to e to power I alpha minus 1 divided by 1 minus e to power I alpha. Yes? But what is the answer to this one? What is the answer? These two are more or less the same, so I have to factor a negative sign out. Yes? So I have divided any number by its opposite. So the answer is minus 1. So that was a good problem, I would say. It's a good problem in using Euler's formula. Yes? Understandable? Okay, good. Okay, let me write you another question, which is a combination of this one and Math 5, okay? So let x, y, and z be the following three sets in complex numbers, okay? So these are the sets provided for you. The set x is defined to be the complex numbers. This is the set of complex numbers such that imaginary part of z is greater than or equal to 1. This is the set x. It's a set containing of some elements from the complex numbers with that property. And then another one is defined to be like this. Y is the set of all complex numbers with this property, that absolute value of z minus 2 minus I is equal to 3. Yes? And finally, another set z, capital Z, is equal to the set of complex numbers with that property that the real part of z times 1 minus I, the real part of that is square root of 2. Yes? x, y, and z, and they have asked you what is the cardinality of x intersection y intersection z. So what is the cardinality of the intersection of these three sets? The number of elements. Do you remember from Math 5? And they have proposed you some answers. 0 means that the set is empty. 1, 3, and infinitely many. Okay, so what is the cardinality? 0, 1, 3, infinite. Okay, I want to wait for you because that is not some. This is from the previous lessons actually. Is the question clear? So I am giving you three sets with some defined properties. We intersect them. What do you remember? What was intersection? The common point. The common points. Yes. So then it becomes a new set. In that set, we want to see how many elements are there. Is it 0? Is it 1? Is it 3? Or infinitely many? Okay, so I want to wait for you to see how. And I don't have the answer. Might be I will try to find it somewhere in the book, but we will see. How is it going? So by the way, this is 3 Math 4 problems, yes? So forget about the language of set theory that we have used from Math 5, but this can be a question in Math 4 itself, yes? You remember we talked about these things. Forget about these conditions. I can ask you, go on the complex plane and sketch what represents this. And I can ask you the same question here. So this is 3 Math 4 problems stated in set theory language. That's it. So in principle, you need to you need to go to complex plane and try to sketch somehow the graphs or the figures that somehow represent these three, and then see that where is in common for all of them. Okay? So even if you don't know Math 5, you don't need to stop here. You can just solve 3 Math 4 problems. Yes? Find this, find that, and find that. Okay, let us see why this is going so long. Okay, so first of all, let me start from Z. How can I find? I want to sketch a graph. If I want to sketch somehow a region in the complex plane which represents this, how do you do that? So my question is that I am looking for all complex numbers Z, so that when I multiply that complex number by this fixed complex number, the real part of the product becomes the square root of 2. It's not easy to guess this, okay? So it means that you have to do some calculations. Okay, so what I mean, so what is the standard way to tackle this problem? You want to go to complex plane and try to find all those points that satisfy this. Sorry, why I wrote this here. This should be here. The answer should be square root of 2. But what is the standard way to do this? We talked about this several times. Yes. What is the standard way here? So I would say let the complex number that I am looking for to be x plus iy, yes? And then what I do, I would multiply z by 1 minus I to see what happens. It becomes x plus iy multiplied by 1 minus I, yes? And then I do the multiplication, x minus ix plus iy plus y, because I times minus I is minus I squared, which is 1. And then this becomes x plus y plus I times y minus x. Agree? So what I have done, I have actually written z in its Cartesian form, and then I multiply that by complex number 1 minus I, and I did some simplifications, yes? And now if I ask you what is the real part, so this means that the real part of what? The real part of z1 minus I is equal to this number. Do you agree? But on the other hand, this tells you that x plus y, which is the real part, should be square root of 2. So this means that by this calculation, I realize this is nothing except saying that x plus y is a square root of 2. Yes, but that's what type of, what is this one? What is the figure represented by this equation? What is that? At least tell me this. What is this? X plus y equals to square root of 2. Is it a square? Is it a circle? What is it? What is this? It's a line, isn't it? So you are confused today probably. Y is equal to square root of 2. Y is equal to minus x plus the square root of 2. Compare it with y equals to kx plus m. So the k value is minus 1, the m value is square root of 2, okay? Okay, now let us try to draw the picture here somehow. Because for this one, you don't need to do some calculations. It is extremely simple. But for this one, if you have forgotten, you have to do some calculations. But I talked about this particular question a lot, yes? So can you tell me what is represented by this equation on the complex plane? So what is this one? Let me just go and draw the picture at least here. So here you have to be relatively careful about the scaling somehow. Yes. That one, if I want to draw this one, it is simple. Yes. It is a line with a slope -1, and that passes through square root of 2. So assume that this is a square root of 2. Okay. For example, if this is a square root of 2, and the same length here is square root of 2, I hope that you agree with me that this line that I am drawing is that line represented by that equation. So that is x plus y equals to square root of 2. Yes? That's this line. Okay, but this one is very simple. I am interested in all those points z whose imaginary part is either 1 or larger than 1. You really don't need to calculate anything, yes? If this is a square root of 2, 1 is somewhere here. This is 1, for example. And then this line, the horizontal line, every point on this line has imaginary part exactly equal to 1. Which is acceptable, equal to 1 is acceptable, but I am also interested in all those points which are above this line. Yes? So for this one, you need to somehow color everything up here. So if I ask you what is the complex, what is this set? This is the set Z. Yes? And this blue one is the set X. So can you tell me what is the common parts zone? Because we are interested in the intersection, so we are interested in common parts. So far, what is the common part? The common part is this part of this line. Do you agree? Because I am interested in all those points that are lying on this line and in the blue region. So hopefully you agree with me that so far this is the common part. And if I ask you how many points lie in that common part, infinitely many. Yes? But there is another constraint, and I hope that you haven't forgotten. This is extremely important, by the way, for Math 4. So what is z minus 2 minus I equals to 3? Is it a line? Is it a circle? What is it? So you know, this is very famous, by the way, so you should know about these things. I take a minus sign out, it becomes 2 plus I equals to 3. Do you remember? I told you, remember this geometric interpretation of the absolute value of the difference of two complex numbers. It's the distance between 2 points z and w. So this means that the distance between z and this fixed point, it should be equal to 3. Then it becomes a circle. Yes? A circle whose center is 2 plus I and its radius is 3. Then I have to be a little bit careful here now, because where is 2 plus I? This is the square root of 2. Yes? 2 should be a little bit larger. This is, for example, 2. And then 3. Okay, and I is here. So the center of my circle is here. This is a little bit crazy, yes? So this is the center of my circle. This is I. This is 2. So this is the center, but the radius is supposed to be 3. So if the radius is 3, if I want to sketch it, so let me just change my color. So I go 3 units down. 1, 2, and 3. I go 3 units up, so I reach to 4. 1, 2, 3. Yes. So this is now 1, 2, 3, 4. Yes. Here is 4. Here is what? Minus 2. And then I go 3 units to the right. 1, 2, 3. 3 units to the left. It is 2, so I go 1 unit here. It's minus 1. So I don't know if I can draw the pictures. It's something like this. Yes? This is the orange one. It's a very nice circle, okay? Anyway, that is enough for our purpose. Now if I ask you, so this orange one is y. Now if I ask you, so if you are in Math 4, you don't have Math 5, you should be able to do all of these things so far. But then, of course, you don't know about x intersection y intersection z. Might be you cannot do this part because you don't know these symbols and things like that. But this symbol means the common parts. That's it. So I am looking for all those points that are in all those parts simultaneously. How many points are there? Can you tell me about that? Which point or points lie in all those sets simultaneously? How many? 1. Yeah, and that is this point, yes? That's it. So you finally found the points, yes? So the answer is 1. There is only 1 point in this intersection, and that is this point. If they ask to find the intersection point, you should also be able to do that. What you need to do, you need to write an equation for your circle, which is not hard, and then you have the equation of this line and set up a system of equations and solve it. And of course, you will get 2 answers, one here and one there. This is not acceptable because, for example, it lies in the 4th region. The one which is in the 2nd region is acceptable. Then you can ignore it. So that was a problem. So I mean that this is 3 problems in Math 4 and 1 problem in Math 5 combined to 1 single problem, 90 seconds, yes? Yes, so you should be able to do it very quickly. Not try. I don't know exactly the time, but might be this should be around this time. Okay, so I think from these, I would say that this is not a standard. So this, if it comes in Math 4, probably it's an A-level question. Because we already talked about this. This is extremely simple. If you see the book, this is E-level question in the book, that you should be able to draw this part. This one is a little bit harder, but we talked about this, that's also in the book. But might be this is the better one in this regard, okay? Any questions? Is that understandable? Okay, let me write another question for you here. Let me keep the board the same. Still we have some room left. I want you to prove an identity in complex numbers. I would say that that's also included in the book. Z and W be complex numbers. Numbers. Okay, prove that this is indeed the case. If you take Z minus W absolute value squared with Z plus W absolute value squared, then this becomes absolute value of Z squared plus absolute value of W squared, and then multiplied by 2. Okay, so we want to prove this. Z and W can be any complex number. We want to prove that this is indeed the case. I will wait for you, okay? Okay, so let us solve that problem. So we are supposed to prove that absolute value of Z minus W squared plus absolute value of this one squared is 2 times absolute value of Z squared plus absolute value of W squared. I told you whenever we are dealing with absolute value squared, you need to remember this formula. You remember, we learned that absolute value of Z squared is related to its conjugate like this. It's, of course, you can say that let Z be a complex number, x plus iy, and then W be equals to x prime plus I prime, iy prime, and then do a lot of calculations. This will work, of course. But this is easier. Whenever you have absolute value squared, you need to remind yourself of this very simple compact formula. Okay, so what I can do, I can start from the left-hand side. Instead of this expression squared, I write the number itself multiplied by its conjugate. So it becomes Z minus W multiplied by Z minus W totally bar. And then I will do the same thing here. So this becomes Z plus W multiplied by Z plus W totally bar. Yes. But we learned that this bar can be decomposed for one bar here, another bar there. That was one property which we learned. This becomes Z bar minus W bar plus Z plus W, the same thing here, Z bar plus W bar. And then I multiply them, so it becomes ZZ bar minus ZW bar minus WZ bar plus WW bar. I'm just multiplying here. And the same thing here, so it becomes ZZ bar plus ZW bar plus WZ bar, and then plus WW bar. And then the first one becomes absolute value of Z squared, but minus ZW bar and positive ZW bar are cancelled. Minus WZ bar and that one are also cancelled. And this one becomes absolute value of W squared. This one becomes again absolute value of Z squared. This one becomes absolute value of W squared. And then I have 2 of them and 2 of them. So I can factor the 2 out. And that is equal to the right answer. Yes? And there is also a nice problem here. I just write it for you and solve it myself, but I want you to see it. So, an inequality is given to you, z minus 3 plus 2i is less than or equal to 4. Yes? Yes. And then you are supposed to find the difference between these two things, yes? If z is any number that satisfies this equation, you are supposed to find maximum of absolute value of z minus minimum of absolute value of z. So this is what we are supposed to calculate. It's a nice problem. The algebra is not involved, but it is conceptually a good problem. So z is a point that satisfies this inequality. There are infinitely many points, we will see why. Among all those points, I want to calculate the maximum minus minimum of the absolute values. But again, this part might be hard, but this is Math 4 problem. So how can you interpret this? Absolute value of the difference, I can write it as, I can factor a minus sign out, is less than or equal to 4. This means the distance between z and this point is supposed to be 4 or less than 4. That's very simple, yes? So what I do, I go to the plane, real part and imaginary part, and then the real part is 3, 1, 2, and 3. The imaginary part is negative 2. So this is the center. So the distance from z to this point should be 4, which becomes a circle, or less than 4, which becomes inside the circle. Yes. So if I want to do that, I have to go 4 units to the left. So I have to draw some sketching some here. So 4 units to the left. This is minus 1. And then I go 1, 2, 3, and 4, 4 units to the right. Yes. 1, 2 here, and 1, 2 here. Something like this, okay? So I have to draw this graph. Yeah, it's a very bad picture, but that's it, yes? So this is the circle, yes? Centered at this point whose radius is 4, but I'm interested not only equal to 4, but less than 4 is also acceptable. So it means that all the points on the rim and inside the circle is represented by that inequality. Yes? This is Math 4 problem. It's not hard. It's a standard problem, a C-level question. But the point is that how can I interpret the maximum of this minus the minimum of z? So it means that you are somewhere on the rim or inside this circle, but you are interested in to find the maximum possible value for the absolute value of z. Can you tell me how should I do that? Only concentrate on the maximum absolute value of z. You need to interpret absolute value of z geometrically. What is the interpretation of absolute value of z geometrically? Distance from where to where? To 0, to the origin. The complex number z, the distance from z to the origin. So this measures the distance of a point to the origin. You want to maximize it on the one hand. On the other hand, you have to be in this region somewhere. So where do you think I should be to maximize my distance to the origin? This is my center. So you have a circle, okay? So the origin is somewhere here. So here is the origin, for example. You want to be on the rim or inside this, but you want to maximize your distance from this point. Where do you think I should be? For example, if I am here, the distance is not maximized. Yes, I can be here. The distance becomes longer. So where do you think I should be exactly so that the distance to this point becomes maximum possible value? And if you want, I can draw the center here for you. So this is the center. I just want to draw it here because might be that's a little bit. And this is the origin. I hope that you agreed you have to be on the rim somewhere. Because if you go in, you are making the distance shorter. So, but where on the rim? Makes your distance to O as big as possible. Where? It's intuitively clear, isn't it? Where is that? I have to connect these 2 points, yes, and just draw this. Yes? I will get 2 intersections, one here and there. I hope that you agree this is the minimum possible distance that I can get to the O, and this is the maximum possible distance. I don't know, can you, do you understand that? Yes? This is the shortest distance, this is the longest distance of the rim, of a point on the rim to O. Yes, of course you can prove it, but I think intuitively it is clear. So it means that this is the maximum of Z. This part is the minimum of Z. But how can I calculate this? It's not hard. Do I know the radius of the circle? Yes, the radius of the circle is 4. Yes? So the radius of the circle is 4. If I know this distance, when I subtract this distance from the radius, I get the minimum. And when I add this distance to the radius, I will get the maximum. Yes?
The origin is also a point.
Pardon?
The origin itself, can it not be? It satisfies the conditions.
Ah, yes, yes, yes. Exactly, exactly. So that's a good question. Yeah, thank you for letting me know about that. Yes, you are right. I was careless. I was thinking that I have to be on the rim. Yes? I don't have to be, because this is inequality. Might be that would be better if they ask you questions about if... Okay, so you are right. The minimum is 0. Yes, the minimum is 0, sorry. But if I want to be on the rim, then you are right. So yes, here the minimum is not this distance. This is the minimum from the rim to that point. You are right. So the minimum value is 0. Thank you for correcting me. So the minimum value is Z, because I am interested on all these points, not just the points on the rim. Okay, but I think the maximum is correct. Yes, the maximum is that one. And what is that distance? What I need to do, I need to go and find this distance. But that is easy, because this point I know the coordinates. What are they? This point was 3, this point was -2. So if I want to find this distance, it is the square root of 9 plus 4, which is 13. Yes? Okay, so then I know the radius is 4. So the maximum distance is this distance, which is the square root of 13, plus the radius. But the radius is 4. So the minimum is 0, but the maximum of Z is 4 plus the square root of 13. Yes? And then the difference is just this number. Yeah, that was a very nice point that you actually realized. Yes. Thank you. Any questions? Okay.